All right, thank you. Hello, everyone. Hopefully, you guys can see my screen. Give me a thumbs up in the chat if you are seeing it. With that being said, I would like to start with a very near and dear topic to us, and which we are going to talk here, is we have been using and talking about GraphRAG. It's not a new thing. It's been there for months and years now at this point. But what we also realized while playing with it is before we can generate an answer for a customer question, we need to better understand the question, especially when we are talking about a critical infrastructure which Cisco provide with routing and networking and all that. It becomes that much critical that we don't provide wrong answers. And with that being said, I probably say something in the chat message if you have felt this. When you ask question in either ChatGPT, Gemini, or any other system, sometimes you ask a question saying, hey, I want an answer for this. But you realize, no, that's not enough detail. I need to provide more because the answer was not at all what you asked for. So in a sense, I'm a big fan of Harry Potter, and there's a good statement in one of the movie series. There is the room of requirement, which is like, if you have to ask, you will never know, but if you know, you need only ask, which is almost like you actually need to know what to ask to get the right answer. And that's exactly what we felt with the system which we started building. Is like, if you don't know what to ask for certain version, certain problem, giving the right context, the answer does not actually reflect what you are even looking for. And that's exactly what we came here and wanted to share our experience and how we have tried to solve it. That's being said, just to understand the audience here better, I have three questions for you. Please comment in this space and let us know, like, how many of you have, I'm sure at this point, a lot of you have created a RAG-based application. It's a few line of code. There are so many libraries which will help you do it. Then have you played with the classic naive RAG kind of system and the GraphRAG already? If you have, please respond in the chat. And on top of it, when you were building this, how many of those have actually gone to production? Have they been used at scale where you are getting a feedback from the users and the customer and who are basically using like, this works, this doesn't work? So please share in the chat because that will help us out to make sure we are covering the right thing for you. Now, I know most of you already know this, but just wanted to make sure this is like a quick gist. RAG, when I say retrieval augmented generation, is more simplified version is here, right? Which is basically two layer when we talk about RAG. One is ingestion, where you take a document or documents, basically convert and split into them, split into multiple chunks, embed them and store in any sort of vector store. And then when the retrieval happens, somebody asks a question, there is a similarity search which happened with those vector, and then a prompt gets added, goes to LLM, and finally give you the answer. Very simplified version, but hopefully it gives some idea when we say RAG, what we are referring. Now, with that being said, a quick introduction here. So I'm Vivek. I work in Cisco Customer Experience Center. We have been working on spatially RAG and have created certain solution which is now being used thousands of times a day. And also we have learned over the period of time what we thought will work and not. And based on that, we were able to give some, generate some paper, research paper, as well as patent. Over to you, Raj, for a quick introduction before I proceed.
Yes, thanks, Vivek. So hey guys, I'm Raj. I'm also from the customer experience team at Cisco. So we have been working specifically on RAG, GraphRAG, knowledge graph from a long time. And we have been solving some of the problems where customer is asking vague questions. And a lot of the state-of-the-art RAG systems were not able to handle that. So one of the project that we had in Cisco was called AID, which is Assisted Intelligent Dialogue. So in this session, you will understand why that system is called Assisted Intelligent Dialogue. Over to you, Vivek.
Thank you. Thank you, Raj. With that being said, I think agenda is very straightforward. We're going to convince you why the classic RAG has created so much problem, at least when we dealt with, why ambiguity to the customer or user query is so essential to clarify before we even generate the answer. How does knowledge graph fit in? what is the overall loop. And actually, it's not just going to be a talk, a live demo of how we have achieved that. And some of the lesson learned, which we would like to share with you all, which can help you to build your own system. But before I deep dive on the things, I do want to call out that RAG is good if you are doing in the classic RAG and then the basic RAG, all is good when you're doing small level of deployment. When I say small level, it might mean thousands of documents with very specific domain stuff, right? However, if I take a challenge like we did in the Cisco side, we have so many product and solution how customer deploys those. And that multiplies the way how customer even asks those questions. So for example, a simple question is, how do I upgrade my Cisco switch? Now, the commands for upgrading a Cisco switch or any device will differ based on the versions. And we have documents across many versions which gets published. So if you ingest all those, there's so much overlapping information, and you almost have to do a needle in the haystack between all these documents for the right version to provide the right detail. Similarly, if I have to say, hey, give me the steps of configuring something, in this case, calling in WebEx, you have to provide all essential steps. So there need to be a complete answer. If you miss something, there might be a problem that customer might not even complete the configuration, or if you miss in between, that itself is a big deal. On top of it, if I bring another perspective, which I think is very near to us, and that's the motto of the session, is how do you schedule a meeting? Like from where? Are you going to schedule a meeting from your WebEx app, Android, or maybe something else, right? Or some sort of other integration. You need that clarity to give the right information. Otherwise, the answer will become very generic. And the other example, which I think happens quite often to us coming from customer experience, is there's a log line where customer brings up as like, hey, does this match with something, or can how any steps to solve it? And if you have to take those, and if there are images in a lot of those documents, how do you basically bring that analysis together? Now think about, these are just sample, how you can take this user query, giving the wrong or incomplete answer and impact of it. And there are many more causes for it. And multiply that when you are building aid-like system for an organization. So that becomes a very big problem, which we targeted to solve with aid. And that's the whole idea of the session. And we're going to focus on one specific problem so we can explain as we navigate through the journey and take you through the journey of how we have identified the challenges and direction to fix it. So I'll take a simple example, which we are going to continue driving. So a meeting is slow. That's like a user query. But what exactly is slow? Slow to join a meeting? Slow to start a meeting? Is there slowness because when you're trying to share a screen, then that's what is slow? Or there's a delay in audio video. Like there's so many interpretation of this question. And before even asking the right, like before we even ask the right question, the answer has very high chances of being incorrect or not relevant to the user. So when we look into this problem, how do we solve it? At this point, I know we have so many good reasoning models, but that is also a costly business if you continue doing thousands of those loop over and also add latency on top of it. So how do we actually get the right context added based on the user query so we can actually give the right answer? And before we even give the right answer, how do we direct and nudge our users who's asking this question to say, you know what, you asked that question, but I need XYZ information before I can actually give you the accurate details. Now, how do we address these problems? And actually, before we addressing, let me divide this whole problem into 3 questions. So what we need an clarifying engine, a clarification engine, a probing system, which need to understand based on the user query, what format of the domain and basically convert that into a question, right? And on top of it, when you are converting that to question, how do you know what is the nearest part which is related to the customer query so I can actually make a follow-up question out of it? And at the end, how do we know when to stop? If you keep bringing the question repetitively, obviously the customer and the user will get frustrated, and you don't want that to happen. So with these things keeping in mind, how we have solved the problem, and that being said, over to you, Raj, to take it forward with the solution.
Yeah, thanks, Vivek. me share my screen. So before we go to the solution, so let's take a step back and let's try to brainstorm this. So this is going to be a brainstorming exercise from now on. We know the problem. We have figured out that when customer queries are ambiguous, no matter what state of the art RAG system or any model we use, will not be able to get the right answer. So we need to design the system. So as part of this, we will do that. So let's try to understand how do we solve this problem now? So should we? So the problem was WebEx is slow, but I don't know which, like whether it was lagginess, whether it was slow in joining a meeting, starting a meeting, all those things. So should we retrieve like everything from our RAG system or vector database and then create a probing question to the customer? Do you think that's a feasible option? Probably not. Then, okay, if that is not the way to generate a probing question, how do I generate it? Should I just have some random prompt-based probing mechanism? Like every time a customer asks a question, ask, go back and ask him 3, 4 questions or 3, 4 parameters. That works well when your system or your document corpus is very small. But what about you are talking about a corpus of maybe 10,000 plus documents? You cannot hard code every permutation combination in your prompt. Yeah, are there any simpler ways of solving that? So let's take a deep dive in each of the mechanism that I have discussed. So the first one, I like to call it the top K trap. Now, our problem statement is very clear. We want to use top K retrieved documents or chunks from our vector database and then create probing question. I'm assuming everybody is aware of vector database, RAG. Just raise your hand in the chat if you are not aware. I hope my colleagues will help you in understanding that. So the first problem comes with this approach is you retrieve top K. Let's say we start with K equal to 50. So I retrieved 50 chunks. But what if the customer's actual intent, think about the same example, WebEx is slow, and he's thinking about starting a meeting or joining a meeting. Now that particular intent is hiding in 51st chunk, but you retrieve 50 chunk. So how do you solve that? Okay, we can probably increase the, we can have some kind of recursive logic here that, hey, we asked that we use 50 chunks, did not work, let's increase 50 to 100. If it doesn't work, let's increase to 200. What you are ending up doing here is you're wasting tokens. You are wasting tokens not to generate an answer, but ask one question. And you don't know how many rounds of this question will go on, right? But if you have 2 rounds of questions with 200 chunks every time, you have used basically 400 chunks just to ask, clarify the intent of the customer. That's not a right approach. So this is the problem. So your top K results might not contain the true intent of the customer. So what do we do next? The next thing that comes to the mind is metadata filtering approach. Again, this is another classic RAG technique where when you have a lot of documents in your corpus, you try to tag them. You tag them with maybe WebEx, tag some of them as slow. Now, what is the problem with this approach, right? Let's take back that example. I have 10,000 documents. Okay, let me trim it down. I have 1,000 documents, and 500 of those documents are talking about WebEx. And then there are maybe like 300 documents, which is talking about slowness. Now, I have tagged them. Now, what should I do here? Should I retrieve 500 plus 300 documents, which is 800 documents, and try to correlate them and ask a probing question? Probably not. What if I just pick up like 400 documents and first try to understand whether the slowness is about WebEx or not, and then pull the slowness documents? It's possible that those documents from WebEx and from slowness might not even, like there will be some documents, there will be some overlap, but there will be a lot of other slowness related concerns, which has nothing to do with WebEx only. So how do you solve that problem? So the problem, if you see the direction where we are going, this is not a chunk or like retrieval related problem. The problem here is we do not know the intent of the customer. And one problem we saw in top K was we cannot fetch too many chunks because too many chunks could lead to latency, could lead to token wastage. Metadata filtering was good, but metadata filtering cannot connect WebEx tagged documents to slowness tagged documents. There would be an overlap between them where WebEx and slow are there. How do we find that connection? So we do not need more data, we need relationships. So that's where we change our approach from a traditional RAG-based retrieval to a knowledge graph-based retrieval. So I'll go in detail like how knowledge graph is going to solve this. So let's try to design the solution ourselves. So what is happening here is if you see the customer has asked a query and we have detected that there is a named entity here which is probably a slow and another one is WebEx. So we enter the graph here. Now your knowledge graph can not only relate like entities, but it can also act as a decision tree. So if you see in this example, what is happening is when I enter the knowledge graph and I see a node called WebEx, I see there are three paths in this. There's one path which I'm calling it as hypothesis one, which is like related to just some join issue. And if you traverse this path, you will see that there's the immediate depth one node is talking about slow join time. Then there is another path, which is that hypothesis two. And if you look at the first depth one node, which is talking about leggy screen share. Similarly, if you go to the third one, you will see poor video and audio. Now here, we take a step back and we try to understand because I cannot traverse all the path, right? So this becomes a hypothesis disambiguation problem now. So what we will do here is we know these entities here and we know how they're connected to the WebEx. Then I will go back to the customer here. I'm not retrieving any chunk. I'm only looking at depth one, which is just a node. Node is just an entity, which is probably a word, something like that in the knowledge graph. So I'm basically using this and I'm looking at the relationship with WebEx and then going back to the customer and we'll ask a probing question. Hey, are you facing something while joining a meeting? Are you facing something while sharing your screen? Are you facing something with audio video quality? And then the customer will give me the right path. And that's where my hypothesis from three will collapse into one hypothesis. And that's when I will traverse that particular path and give him the right answer. So let's understand this as a let's try to be applied AI architects and try to design this system. So what we are going to do is we'll have like four agents. First agent we want to call it as detective, which is basically trying to understand ambiguous queries from the customer and invoke this workflow. Second one is a strategist, which is basically looking at the knowledge graph and doing reasoning here. Third one is the interviewer, which is basically using the reasoning from the strategist and creating probing questions for the customer. And the last one is your expert. So expert is basically, you have everything. It's a typical RAG agent that retrieves chunks and then gives you the answer. So what happens here? First, when a query comes in, we basically check whether the query is vague or not. It could be an intent classifier, as simple as that. If it is not a vague query, then we go out to our happy path, which is go and do a RAG retrieval and give the answer. But if it is a vague query, then we go to the strategist agent, which basically goes to the knowledge graph, tries to reason there and basically tries to solve those hypothesis problem. Once it figures out multiple hypotheses there, it will come to the interviewer and the interviewer will ask probing question. It is possible that in this stage, only you have resolved it, but it's possible that still there are ambiguity left. Maybe you started off with 10 hypotheses, you collapsed it into 5 hypotheses with the first probing round, but then still there are 5 hypotheses. Do you want to give a very bloated generic answer? Obviously not. So then you again do another round of probing. Then after that, maybe it turns out to be from 5 to 2 hypotheses, and then you basically give your targeted answer. So this is a simple implementation of that from a line graph. So if you are aware of line graph, all those agentic workflows, you will be able to relate to that. Um, so let's go through this entire example now that we have been talking about, where a customer came to Cisco and saying WebEx is slow. How do we solve that problem? So a detective agent comes in, and then detective agent detects that there's an ambiguous query because of the slowness, and it goes back to the strategist agent. The strategist agent is basically going into this knowledge graph, and it sees that there are multiple things where slowness could be possible, because there are because we are creating entities based on features. So the first entity was meeting, second was screen share, third was audio and video. Now WebEx, from there, it can basically figure out that there are 3 different paths where slowness could be possible, and then using those entities, it goes back and asks a question to the customer. Now you can see that here. What then? If you remember the flow from the strategist, we go to the interviewer. An interviewer is basically asking now, can you tell me which part of WebEx is slow? Because I see 3 different paths in the knowledge graph. So the customer says, I'm facing a problem in joining a meeting. Now, if you look back here, when a customer said it's about joining a meeting, I do not need to care about these 2 paths. It becomes a simple, happy path now, and I can just go and do a targeted retrieval and give a more targeted answer to the customer. So let's quickly go through a demo so that we can see that in real time. So let me open for production system. So this is the WebEx chat assistant that we use in Cisco. So let me ask a different question here. So, okay, how do I schedule a meeting, right? So while I ask this question, I also ask that question to Claude, which is the state of the art model right now. I'm using Opus 4.6 extended thinking. So that's the best I could get. Now I asked the same question. I need help to schedule a meeting. Can you share the steps? Now, if you look at the answer, it is more of a philosophical, or it's a completely different type of answer. And I don't blame Claude or Opus in this, because this is an ambiguous query. I never said from where I want to schedule a meeting, what device I'm going to use to schedule a meeting. So I'm just giving a very generic question. So the Claude is trying its best to give me a very generic response with some of the targeted things, like define the purpose, identify attendees, pick up a location or platform, things like that. Now let's go back to our production system and see what is happening here. So you see, when I asked the same question in this system, it came up with some probing questions. So let me put the answers. So which application or platform you would like to use? This is a WebEx chat assistant, but probably I don't want to use WebEx. I want to use Microsoft Teams. Let's see what happens there. So it doesn't matter. Third, what type of device will you be using? I'll be using mobile device. Okay, so it will take some time. So let's go back to our Claude and try to understand why it failed. I was using a flagship model. I was using a chain of thoughts, or like the thinking mode of that. The problem is it can think, but it doesn't have the visibility in the ingested content is there. So the problem here becomes not a thinking problem. Problem here becomes an hypothesis ambiguation problem. You look into the ingested content and then you figure out what to ask from that. That's why it became a very generic response here. Now going back here, okay, it asked me another question. So just for the interest of time, I'll quickly show the one that I had. So if you see here, what really happened here is when I gave that same answer, Teams, smartphone, mobile device, and doesn't care about how many participants or what kind of roles I want, it gave me a very targeted answer. from Microsoft Teams, even retrieved images from that. And it's a very detailed answer. As a customer, that's what I want. I don't want a bloated answer where I need to apply my brain and try to figure out from there. So that's how we are solving this using the mechanism that we discussed. So going back to our session again. So what did we learn? So we have solved this problem, but we want to share some things with you, like, from our production deployment here. All those things that you have observed today works fine. It works really good. But what matters is your graph quality. If you do not create that knowledge graph in the right way, you saw in that knowledge graph how it was created, right? Every feature was its entity. Every entity had a relationship in a well-defined way. If you do not have that, you will not be able to solve this problem. You will be wasting probing attempts and then end up frustrating the customer. The second thing is, it's very important to understand that when to ask a question. It's not that you always have to ask a question. You first have to detect that ambiguity first. And if there is a real ambiguity, and that ambiguity is not a very generic ambiguity detection, that ambiguity detection should happen from your ingested content, what you have ingested and what the customer is asking. You need to have some correlation there. And that's when you decide that, hey, it's possible that customer is asking a very generic question that, hey, help me decide my next vacation. I ingested only WebEx articles, right? So I should not go back and ask, can you tell me what device will you use to, schedule your vacation and things like that, right? So that's why it's very important. You need to identify the ambiguity in relation to what you have ingested in your knowledge graph. The second is, while you are doing this, you will realize that there's a new type of evaluation metrics that will come in the picture, what we call it as dialogue efficiency. Now, why it is very important? Why normal RAGAS metrics are not enough? Now, how many probing questions should you ask? And how can you tell us that the probing was able to disambiguate the hypothesis space from maybe n to 1? So we need to measure those things. That's when we can basically say that, yes, this mechanism works. And with all those things, we were able to deploy a production gate rack system in Cisco, which is solving, like you saw that, like as soon as I go into WebEx, help.webex.com, and I can basically trigger a flow there. Similarly, we're also solving a lot of troubleshooting customer problems in Cisco using this design. Now, key takeaways for us. You remember we started off with assisted intelligent dialogue. So RAG is not a monologue problem. You can convert RAG from a monologue using to a dialogue by creating a reasoning loop and creating probing questions. And you should use knowledge graph to basically figure out that. A knowledge graph is not only to find entities and relationship, you can create your own reasoning loop. So with that, I would end here. And if you guys want to connect with us, let me see. You can always connect with us in LinkedIn. I think we did not have a lot of time to answer a lot of your questions. I hope my colleague was able to help. But any questions you have, feel free to reach out to us offline, and we'd be happy to help.
And thank you everyone who asked the question. I tried my level best to cover as many answer, but as Raj mentioned, please do connect with us, and we would love to have discussion and answer your queries. Thank you.